Okay, so flip over a line or reverse in the other direction. So if you notice on Alex 2 days ago when we just talked really briefly about reflections and you had to like draw that line, remember it looked like the two symbols they do is like they draw a capital R. And then if I was going to reverse that R vertically, and this is like when you take a picture of yourself in the mirror and your sweatshirt, it doesn't read the same anymore, right? You look at Apollo and it says, oh, love, right? It goes backwards. So now when I do this R, this straight edge is actually going to be the far edge. And then as it curves towards the line. So I'm going to start at the top here and curve towards that line and then out. So that's kind of our reflection. As we look at it, we identify kind of what's further away on the left. We're going to continue to have that further away on the right. If we do a horizontal, we're going to have an R, and then we'd have our line below the R. And it's going to flip from up to down. So the way I like to do this is that this straight edge is going to stay on the left side, so below it's going to have that straight edge. And then this curve happens away from the line. It's further away. So down here at the bottom, I'm going to have that curve. It stays on that right side. So this curve was on the right side, stays on the right side. And then we get that extra little guy there. So it's not perfect, but when we do it on a coordinate plane, it's going to make it easier because we'll actually have points to reflect, and it'll make it a little bit more exact. All right, I'm going to pass out your glue in today. You can go ahead and glue it in just either on the left or the right side. So you don't need to cut it. As you find your glue, you might want to find a ruler and 2 colored pencils today. 2 colored pencils are going to be what I use to help us look and see what we're thinking. And then a ruler is just nice for you to check your shapes and make sure they look somewhat the same. So find your glue and then go find 2 colored pencils today. And 1 ruler. You might need to try the ruler or a straight edge. Remember, you can always just use like the side of your lunch card or the side of your phone or the side of a whiteboard. So when you glue it in either on the left side or the right side, so you can leave the space in the middle blank so we have space to show our work. Shouldn't need to cut it unless you started your notes halfway down your page. If you're somebody who you don't do a new note sheet every lesson, if you are a continuous person. Some people like to do that. I think that's crazy. But you do you, bro. Alright, I'm going to use orange and blue today because they'll show up really well on my screen. So if you want to grab 2 colored pencils and then get that glued in, if you want a ruler so you can draw those nice straight lines. Hearing a lot of digging around yet. I know I haven't organized those bins in a while. If you want to help organize them, you can just organize them at your feet. All right, really quick, I forgot to announce that we have a guest in our room today. We have another VIP. Yesterday we had a VIP. It was Mr. Kwan. It was his Thursday back after break. Today Mr. Kwan is on a field trip, so we have a person, a substitute. We switched him out for another person. Remember?
Mrs. S.
Mrs. S, Mrs. Shep.
Shep.
You? Awesome. Awesome. Well, welcome.
Do you know if I can pass on?
Yeah, we're just hanging out. We're doing great. All right, so here we go. Our first one, we're going to reflect over the y-axis. So as we reflect over the y-axis, one of these colors we're going to use to show what is our reflection line. It's kind of like where is that mirror standing. So I'm going to think that my y-axis, I'm going to highlight that in one of my colored pencils. Again, using colored pencils is really nice. It helps draw our eyes to the important parts. All right, so as we look for that y-axis, which one is the y? The horizontal or vertical? Vertical, good. So our y is here, it's our vertical. And I'm going to just highlight that to show that that's what we're flipping over. So it's going to go from one side of that line to the other side. It's like we're going to reverse it. So it's going to go from this side to that side. If it was on this side, it's going to flip from the right to the left. So this is a vertical reflection. It's going from left to right, right to left. And remember the idea is that we're going to flip it over the line, or it's like we're going to reverse that line. Okay, or reverse that shape over it. So as I take a look at that, if I look at R is one jump to the left. So how would I undo, or how would I reverse one jump to the left? What's the reverse of left? Right. Yeah, right. So I'm going to go back to my y-axis, and I'm going to go one jump to the right. Okay, it stays on that same horizontal line. We're not switching which line we're looking at. Yeah, a second, focus. There we go. So it's still on that same horizontal line, it's just we're going into the other direction. So now as I look at Q is way further on the other side, and this one's kind of nice and easy because it's on the very end. So when we flip it, we can probably assume it's going to be on the end, but let's count anyways. So Q is 1, 2, 3, 4, 5 jumps to the left. So instead of going 5 jumps left, I'm going to go 5 jumps right. 1, 2, 3, 4, 5. So when we think about that reversing, we're thinking about undoing. Opposite direction, we're flipping it. So if I think of P was right underneath Q. So it should be 5 jumps to the left. So that's at -5. If I flip a -5, what would that be? +5, yeah. So I can go to +5 on that x-axis. What about S? S is right on the mirror. It's right on that reflection line. So it's at 0. Where would that be when I flip it? 0. It's like if you touch a mirror, if you put your finger out and touch the mirror, it should look like you're like touching yourself, right? Your reflection is coming back and touching you. Okay, unless it's a two-way mirror, then that's a whole other conspiracy theory. So it's going to stay on S. If it's on the line, it stays on the line. So go ahead and use your ruler. You can connect your points. And remember, your shape shouldn't have changed. It should still be the same size. And that's why using a ruler is really nice. It kind of helps us identify if any of the points changed. Those relationships should look exactly the same. All right, after we draw on those lines, we do need to label and tell our reader which one goes with which. So we started with this point up here. Where did it come from? What was our pre-image? R. Now this is the image, this is the after. So I need to show my reader that this came from R, but it's different. It's changed. prime. Good. So we do R, and then that prime is that little apostrophe. So R prime. And we're just going around and labeling each of those points. So Q prime. And we're just telling our reader which one matched with which. And then down here we have P prime. Now, even though S didn't change, we still want to label it S prime, telling our reader that, yep, it didn't change. We put it through the change, and it stayed the same. Sometimes that happens. When we go through a change, we stay the same. All right, if I take a look at this and we write it as a rule, remember yesterday we talked about rules and writing them as those arrow notations. If I start with an ordered pair X, Y, how is that going to change my shape when I do this reflection? Is the X changing or is the Y changing when we go left to right? Yeah, the X, because remember we talked about going left. If we go left 5, instead we're going to go right 5. And our left and right is which coordinate? Yeah, the X. X goes this way. So our X flips, it reverses. So it's going to be opposite of X and then our Y. And again, this is nice if you're having coordinates that we don't have a graph matched with. So let's just work on that with R real quick. So R started with, what was our ordered pair for that first point, R? So -1, +4. So if I wasn't using my graph, I'm going to cover that up. I'm not going to cover it up because I can't do that without covering everything. My hands are too big. But if I was going to find R prime, all I would need to do is change my X coordinate to the opposite. So what's the opposite of -1?
1.
Yeah, +1. And then the Y, since it's just Y, it's staying the same. So it should be 1, 4. The only thing that changes is our X. So if counting is not your deal, if you're getting confused with these jumps and you're like, what the heck is Miss Morrell doing over there? It's magic. You can always use this rule. Some people are rule followers. Some people are a little bit more visual. It's your choice. All right, we got another one here with the axis. It tells us to reflect over the x-axis this time. So again, I'm going to be using that blue colored pencil. I'm going to use the same color always to show our axis of symmetry, or sorry, axis of reflection. Our reflection line. I don't know the right word for it. Sounds weird. All right, this time we're doing the x-axis. So our x-axis is our up and down or left to right? What? There you go, left to right. All right, and it has that nice x-axis there for you. On Alex today, it'll tell you in the directions to do either x-axis or y-axis, but it doesn't highlight it for you. So you have to make sure you're really reading the directions of which one they want you to reflect it over. And then if you need to highlight that kind of in your mind, make sure that you're doing the right one, locate x and y. So this time, my shape isn't going to flip left and right. This time, my shape is going to flip up and down. So if I start with M, again, this time I'm not going to change my vertical lines. I'm going to change kind of where I'm counting how many up and down. I'm going to stay on that same line. So M is 1 below my blue line. So instead of going 1 below, what would be our reverse? Yeah, 1 above. You guys are whispering it. You're just not saying it. You're silly. All right, so instead of 1 below, M is now going to be 1 above. All right, if I go to K, from that line, I start at that axis, at that x-axis. I count down how many is K. 1, 2, 3, 4. So if K is 4 below, we're going to go 4 up. Good. 1, 2, 3, 4. Thanks, Mubarak, for answering a question. You're amazing. All right, now L is a little bit different situation. L this time is 1 above. So where will my reflection go? Yeah, 1 below. All right, you have those. Go ahead and connect them. Now this one looks a little messy. Sometimes transformations look a little messy because they overlap. They look a little different than, it's kind of hard to tell which one's which, and that's why I really like to use a colored pencil. That helps me realize which one is the transformation, where the lines cross. That one didn't really turn out really nice. Oh my gosh, Miss Morrell. I'm just making it worse. All right. And again, that triangle should look relatively the same when you draw on those lines. It shouldn't look like it got longer or skinnier. It should look exactly the same, just flipped, reversed. After we draw that, we're going to make sure we label so our reader knows. So we have M here. Above, I want M prime. What is our symbol to show prime? That one thing. Comma thing? Yeah, comma on top, apostrophe. Yep. So M prime. Here we have K on the bottom, so on top we're going to have K prime. And here we have L prime. All right, so again with our rule, if we wrote a rule for this one, this is our x-axis rule. If you wanted to write that up there, sorry, I forgot to write that. Our x-axis rule sorry, I wrote y-axis rule up here. You couldn't see that. I just wrote that in because I forgot to write it there. So if you wanted to write y-axis rule up there so you know which one that is. So here's our x-axis rule. Okay, our x-axis rule is we take our xy, and this time to flip it up and down, which coordinate works with up and down motions, the x or the y? The y, so the y flips. So the x is going to stay the same, and our y switches to the opposite of y. So if I take L, originally L was at 1, 2, 3, 4 to the left, -4, +1. All right, and I flip it. When I flip it vertically or horizontally, I'm flipping it up and down. L prime, we're going to keep the x. That's what this first x is telling us. Keep the x as it is. So -4 stays -4. But then we're going to do the opposite of y. So our y was 1. What is our opposite of y? -1. Awesome. Crushed it. 2 more examples. Notes are a little longer today, sorry. Trying to go fast. All right, as we take a look at this next one, Gabe, zoom back in. On the 3rd example already. Put your phone away. All right, as we go to our reflecting over our x equals 1, again, big thing, our x equals -1. Big thing is we need to identify where is that line. Where is x equals -1? And this one's a little different. It's not as just as easy as looking at our x-axis or our y-axis. We actually have to figure out where is x equal to -1. All right, so what that really means, a couple ways we can do that, is we can look for -1 on our x. So where would -1 be on the x-axis? Yeah, left side, and then just 1. So the way my brain works is I find x equals -1. Now if I drew a line through that, if I drew a horizontal line side to side, that would just be the x-axis, and it would say x-axis. So do I want a side-to-side line? No, I want an up and down line. So that's one way to think about it. Another way to think about it is if you make a table, an XY input-output table. Our rule is x is always -1. So we could do -1, 3. Doesn't matter what y is, but x has to be -1. So -1, 4. Sure. -1. Somebody give me a new number here.
5.
I'll go 3, 4, 5.
6.
You're so boring.
6.
No, it's okay. I already wrote 5. All right, -1, 5. So if I plot those points, -1, 3, -1, 4, -1, 5. And then you can see that line that it's creating. So kind of two options there. Either you can find it on the axis, so x equals -1, we go to -1, and then think about how you're going to draw that line. If I just drew it side to side, it would just be the x-axis. We don't want that. So I'm going to draw it up and down. Or you can create a table. All right, this one there's no rule for it. We just have to do the counting method. So this time it's flipping from right to, is it going to go right to left, or is it going to go from up to down? Good, right to left, or flipping over that blue line. So as I count from the blue line, I'm going to start with G. Sure. G is 1, 2, 3 to the right of the blue line. It's only 2 from the y-axis, but we're going from this blue line, our new reflection line. So we're going 1, 2, 3 to the right. So we're going to go back to our blue. We're going to go 1, 2, 3 to the left. All right. H is right above it too. So some people, once they figure out their first ordered pair, the way that they kind of do it is they figure out how to construct it. Like H is 2 above G. This is where my G is, so if I go 2 above, that should be where H is. Okay. Other people, they just like to do the counting. Either way, it's your choice. So from this point, it's 1, 2, 3 to the right. So I go back to my blue line, and I'm going to go 1, 2, 3 to the left. And it did end up right above G. Okay, again, you can think, okay, I is 1 away from H, and it's further away. So if I go back here, I can think further away would be to the left. Or you can do the counting. 1, 2, 3, 4 to the right. So we do 1, 2, 3, 4 to the left. Okay, and remember it should flip, so this one's kind of a nice one because we can see that vertical line is closer to the blue line than that point I. And that stays the same here. We have that vertical line is closer to the blue line than that I. All right, and then just label, make sure that we know which one is which. All right, our last one is reflecting over y equals x. So with y equals x, again, we need to identify where that line is. This line is going to be different than the other lines because this one's actually going to be a diagonal line. So if I think back to just a table, x, y, we can pick an x, any x. Ansel, give me an x. Any number. 3. If x is 3, y has to equal x. So what does y have to be? So our rule is y has to be the same as x. So if x is 3, what does y have to be? 3. It has to be the same. Mubarak, give me another x. Okay, well, 7's not on our graph. A little lower. Yeah, well, we're gonna plot the points. So 5. All right. So if x is 5, then y is 5. Let's do a negative number here. Negative 2. So then y is negative 2. So if I plot those points, that's going to help show where that line is, so that we can figure out our reflecting. So I have 3, 3. So from my origin, we're going to go right 3, and then up 3. We have 5, 5. So right 5, up 5. And negative 2, negative 2. So down 2, left 2. And what ends up happening here with our diagonal is it's all these kind of corners. It matches corner to corner to corner. And it goes through the middle, through that origin. So as you match those corner to corners of those squares, of those grids, and through the origin. All right, so in this one, there's a couple ways to do it. The first way is if you want to do the counting method, you can. It's a little bit more complex with this one. It doesn't turn out quite as nice as the other ones. Okay, but when we do our counting method, we have to do it diagonally. So instead of just counting left and right, we could go left and then down. So to get to, I don't know, it just turns into this complex mess. So we have to go like diagonally. So if I count corner to corner here, rather than counting across. So if I start at I would count down to this corner. That would be 1, 2, and then it goes to 3, and it hits that line. So then I'm going to continue to count corner to corner past that 3. 1, 2, 3. So it kind of creates this diagonal corner. Now that gets a little complex. It's a little bit more challenging to see. If you're a visual person, you like that like abstract, you can just look at it and see it, that might be great for you. This one really screws me up, and I'm a person where I have to have my rule. So I have my y equals x rule. Which tells us that we're going to have our x, y to start off with, our normal ordered pair. And then when I reflect over y equals x, what's going to happen is we just flip those. It becomes y, x. We switch them around. So if I start with I, since that's one we've already done, I originally is -1, +5. All I need to do to find I prime is switch those around. So instead of -1, 5, we're going to do 5, -1. And that's where it ends up being. Our x is 5, and then our y is -1. So let's try that with h. Who can give me our ordered pair for h? So from the origin, do we go right or left for h? Left, how many? Good, -3. And then how many up for h? 4, good. So h prime is going to be what? Good. 4 and -3. Nice job, Ansel. We just switch them around. All right, J, last one. J as an ordered pair is 1, 2. So if I flip that around, what's our new j prime? Yep, 2, 1. So we're just switching them around when we have that y equals x. So that's one way to do it. There's a couple ways to do this. You can do it that way. You can do it with this diagonal way. Some people can just look at it and they know. That's insane to me. All right, so if I do h prime, my new h is 4, negative 3. So 4 tells me to go right 4. 1, 2, 3, 4. Negative 3 tells me to go down 3. 1, 2, 3. And there's my new h prime. Okay, j started at 1, 2, but my j prime is now at 2, 1. So I'm looking at that 2, 1 as a new point. So from my origin, 2 would be to the right 2, and then 1 would be up 1. All right, and then go ahead and shade that in. All right, and that is it for notes. I know notes were a little long today. I don't know why. My brain just is a little slow maybe. And that video was a little longer. For some reason I thought that video was only 2 minutes. It was longer than 2 minutes, so that's why I stopped it eventually. But that is it for that. And then you do have an Alex assignment today. It's in Alex. Remember, to get to Alex, you go to a new page. I think most of us have been into Alex already. I think there's only one of us that hasn't even logged in yet. So if you're that one person, get logged in. Let me know what you need.